I'm naturally loud, so like sometimes I can't tell. All right, so obligatory introduction that was already given by the MCs, but everyone else is doing it, so you know, why not? Peer pressure. So, mixed cast perch. I am a non-binary. I go by Node botanist. In fact, there are people out there who do not know my actual name. They just know Node botanist. Like, I had a guy run up to me at the airport at like 7 a.m. I'm not a morning person. So they run up to me at the airport at 7 a.m. like, you're the Node botanist. And I'm like, oh, am I arrested? Like, it was really funny. But I am a non-native Austinite. There's an asterisk there because I dare you to find someone who lives in Austin who was born in Austin. Because I know one person who lives in Austin who was born in Austin. I've been there since I was 7, so I'm close enough. Anyway, and like you mentioned, I am an electrical engineering student at Arizona State University online, which is kind of coincidence. I will have the same degree from the same school as my father when I graduate, because I was born in Phoenix and he was busy getting his electrical engineering degree at ASU when I was born. So, it's funny. I am a robot and NodeBots author, so I just released my second book at the end of August called Hands-on Robotics with JavaScript, about using your Raspberry Pi with the Johnny 5 framework. There's a few stickers left on the community table for both of those things, so you should check them out. And then that's my booth. That's my lovely partner, Kevin, who's playing with his phone while I was taking pictures of my Maker Faire booth. And then I'm super socially awkward. You should totally ask Sam Richard what I told him as the elevator doors closed on him in the hotel, because it was hilarious to everyone but me. Anyway. I am a cat parent, as they said. Look at those faces. Oh, right. All right. So the one on the left is Arya, and then the one on the right is Ace. Ace is my boy. He follows me around the house all day. Whenever I try to pack, he sits in my suitcase. Not to like say I'm going with you, but like you can't move if I sit on it. It's like, yeah. I am a huge baseball fan. All right. So I usually root for the Arizona Diamondbacks, right? Okay. They won their last World Series in 2001. Rip Yankees. But I also root for the Houston Astros. 2017. Rip Yankees. And my partner was raised as an Oakland A's fan, so in 2 weeks I'll be rooting for the Oakland A's. Rip Yankees probably. Glaze. Anyways, serverless. Okay, this was shouted at me at a bar after a Node conference just after I'd taken this job at IOPIPE. We just spent 10 years convincing people that JavaScript belongs on servers, and now they want to take our servers away. Okay, calm down. We're not trying to take away your servers. It's a really bad name for it. Some people call it functions as a service. I like that name a lot better because it's a lot less of a misnomer. It doesn't mean there's no servers. Just like when cloud computing and EC2 became a thing, we didn't, completely get rid of like DevOps. Like that's still definitely a thing. In fact, more of a thing now that we have to deal with someone else's servers somewhere else. So, what serverless is, it's an abstraction, over 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 an abstraction. So, it facilitates web development in certain situations. So it's kind of like a jawbreaker, right? So like EC2 kind of made servers an abstraction. You didn't really care what physical hardware they were on, you just wanted this type of machine with this OS. And then you go from there. And then Docker was another layer, where it's like, okay, now I also want the machine to have this stuff installed on it and this environment. And so serverless is, okay, now I don't even care like if it's Linux or Windows or whatever, just as long as it runs Node 8 and gives me an HTTP endpoint, good, here's my code running. So that's what serverless is. You're like, oh, dang it, I forgot to hit the button. Like I said, EC2 extracted servers, Docker extracted environments, and serverless we extracted away the runtime. When you go to a serverless provider, you will say, I would like Node 8, or Java, whatever version they're Java they're on, I forget. Golang is becoming really popular in serverless. Python, of course. Version 3 or 2 can be done on serverless. There are some providers that are offering even more languages, like Ruby. And AWS allows you to upload any binary onto their platform and run it as a Lambda function. So, like Rust, you can upload the Rust binary onto an AWS Lambda server. So, yes. So with EC2, you don't have to install an OS, right? You just get a box with Linux, Red Hat, or whatever you want running on it, right? So I'm kind of like elaborating a little more on these as we go along, and I feel like Opportunity kind of helps us learn more and digging a little deeper. And with Docker, you don't need to worry about your dependencies because they're automated. You've got a Docker file, it sets up MongoDB or whatever database you prefer. I'm not trying to play favorites here. Please don't at me with like, oh, they really like MongoDB. No, it's the first one that came to my head. And you can even use Docker on an EC2 instance. So with serverless, you don't even need to worry about setting up anything. You just write your code. That is all you do. You write a function, and it just needs to return whether it succeeded or failed, and then you say, okay, deploy it. I don't care where, I don't care how, just do it. And then give me back an API endpoint that I can call. Why is that a good thing? Okay, so AWS, for instance. On an EC2 instance, you are billed for the amount of time that the EC2 instance is running. Makes sense, right? I mean, electricity and the hardware. Same thing for Lambda functions. But if your Lambda function only takes like 1/10 of a second, and you only run it once a day, instead of spinning up an EC2 instance that'll run for 24 hours a day, that runs that same task, if you convert it to a Lambda function, you're spending a lot less money in the long run. Because you're only spending money on the runtime that you're actually, the time to run that you're actually using. You write code, you deploy code, you run code. But like for real. I know like we've been promising this forever, but like for real this time. You can really just write code and run it. I'll show you that in a minute. And it scales like a dream. And I know, again, I promise, I know we always say this and we're often wrong, but you can, Lambdas and most providers, when you call a function and it's already running, they'll just spin up another one, and another, and another one, and another one. And you can limit the amount of concurrency if you want, or you can just say, no, just go for it, like as many as you need, as many instances as I need of this function, just scale it up. Because we have way more important things to think about than like what machine our code's running on, setting up tons of Docker files for certain tasks. We have much more important like how to fix the problem of the cat wanting to sit in the desk. By the way, the answer is the Ergodox EZ. Because you can see, the split keyboard, I can actually type with him sitting there. That was a far more important problem to me than whether my EC2 instance has Linux or not on it. Like, far more day-to-day problem for me. Example time. So, we'll walk over here. Live coding beings, be nice to me. Please. So, running over here. This is my function. I actually am not going to live code today. I'm going to walk through the code, but I'm actually not going to live code today because I woke up this morning and I had a bit of a fever, so I was just kind of like, let's reduce the amount of failure points since the number of natural failure points is going up. So I'm going to walk you through this code so I don't fall over. So we're requiring an IO pipe, which I'll talk about later. I work for them, disclaimer. And I'm also bringing in the color library, which parses CSS color strings into RGB values. And I'm bringing in MQTT or Mosquito, which is an IoT messaging protocol, which I could give a whole nother talk on, but I can't right now. So I'm starting up IO pipe, and I'm calling some trace plugin. We'll talk about that in a little bit. What I've got is a function called sendColor. And so what I'm doing is I'm looking at the query string parameters. If there aren't any, it says, hey, you need a URL parameter called color, otherwise I can't do anything, and returns a 400. Let's set color and then try, because color throws an error if you pass a string that's not actually a CSS color into it, so I had to add a try catch block to that. And so it says context has succeed here. There's a long story behind that. Turns out if I error out my function, the project kind of wigs out for some reason. If sent color, so like if you actually sent a color that works, we connect to the Mosquito server and we send it a message of the red, the green, and the blue value to the feed node.nist feeds colorbot, which that Raspberry Pi is listening to. And then, what did I drop? Oh, okay, good, it's fine. And then there's an error. I'm also doing a mark.start and mark.end. This is a metric to see how long it takes to connect to the server. And so there's an error. I also want to say like, hey, I'm done trying to connect to the server. And then label that there's an error, and that's it. That's my code, right? So going to show y'all my super, super duper hard, extremely difficult deploy process for this code. All right, I know my terminal. I'm going to ignore the tip of the day. Thank you, iTerm. And then I'm going to do this. Yeah, seriously, the song I had stuck in my head before they got Wonderwall stuck in my head was, I've got a lovely bunch of coconuts, Like, someone did a parody of it for like a Dragon Ball Z abridged show, and like my partner got it stuck in my head, and I told him like, I'll destroy you if that's stuck in my head when I get back from New York. So Florida and Jacqueline saved my partner's life. Because I now have Wonderwall stuck in my head, which is a huge upgrade. I bring all that up because it does take a minute to deploy the actual function, but you notice I'm not actually like doing anything. Like you can see my hands, I'm not quickly typing everything. The only thing I had to do before this was say serverless init, write the code, and put my AWS credentials in a file. That is literally all I had to do before this. And so, my code is online. And the way we know this, go back to the slides here. There's the remote. It is warm up here. I'm really glad I took off my overshirt because I would be roasted. Let's go to node botanist /set and then add the URL query parameter color and then a CSS color. I would recommend using a named color because they're easier to put in URLs like Rebecca Purple or Red or avocado. No, not avocado. Papaya whip. Yes. That's one of them. CSS color, and you'll start to see the Statue of Liberty color change. So like I'm going to do it, and I'm sure it'll get overridden by somebody else, but I'm going to do it anyway. I'm going to go over to my site here, and I'm going to make that bigger. And it says color red. I'm going to change it to I'm going to remember how to type. Like it works. Did that actually change? Please, 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 oh please. Yes. Okay. Hardware demos, they're so picky. Like the fact that that's working, I'm really happy about that. So that's, IoT and serverless are the best of buddies. And we'll talk a little bit about why here when I go back to my slides. Yeah. Okay, first what serverless is not. And that background image is very deliberate. So like, I'm a web developer too, I get it. We find a new cool thing and it becomes a hammer and everything becomes a nail. And then 2 years later we're like, okay, we all hate this thing because we all solved all the wrong problems with it. So I want to be very clear about what serverless is not, because I want to stop that cycle of like us thinking, oh, serverless is going to solve all our problems. Oh God, we hate serverless because we did all the wrong things with it, and that kind of thing. I don't want it to happen. I like serverless for certain things. Serverless is not a panacea. It's not going to fix all your problems. It's not going to turn your 10-year-old Java app into a Web 2.0, you know, whatever. It's not going to wave a magic wand and fix everything. It's great for certain tasks, and you're probably thinking, that's real helpful, Cass. Like, great talk, applause, I'm good. I know what serverless is now, right? No, okay, so I need to be a little more specific. But I'm gonna let my coworkers, who are way smarter than I am, at IOPipe show us with this really cool website we built, well they built, and I kind of helped with some JavaScript. Servers.lol. I'm gonna make this bigger so you can see it. So this is your EC2 via Lambda, but really, this fits any web app, right? So we're gonna start, and we're gonna find out, right? So let's figure it out. What languages are your applications written in? Well, considering we're at a JavaScript conference, we'll go with Node. Can the functions in your app finish within 5 minutes? Let's say no. Let's say this is a task that like chews through a lot of data and takes 10 minutes to finish. No. Okay, so that is because serverless functions generally time out after 5 minutes of work. They are not meant to run for long periods of time. That is what EC2 instances are for. Because Lambda functions, if you run them for a really long time, are actually more expensive than EC2 instances. So you don't want to use them for things that take more than 5 minutes. IoT devices sending messages to each other don't take more than 5 minutes. So we're gonna hit back, actually we're gonna hit refresh, because I forgot this is a 10-page app. Find out. Node. Yes. Okay. Optional. How much memory does your app require, right? You can kind of pull the slider here. IoT apps don't need a lot. We're just going to scale this down to 128. And which graph best represents your application activity? We'll say active and predictable, right? And then we'll pretend we're running an M5 large because I totally have the budget for that on my own. Okay, get results. One app. Okay, so this is because of the way Lambda scales. So it sets up as many instances as it needs, and it only runs for as long as you need it. So it sets up the instance, it runs your function, and charges you for that. It stays alive for a certain amount of time, and then it shuts down if it's not called again. They don't charge you for that idle time, where it's not actually being called. They just leave it running. Now, there is a slight downside to this. The first time you call a function, you may encounter what's called a cold start, which is when they have to kind of spin up whatever magic it is they're using to run your environment runtime, usually Docker, and get your function running. And that can add a little bit of latency to your application. So if you care about that, okay, so they started this practice, they call it keeping serverless functions warm. I call it defeating the point. If you're keeping a serverless function warm, that's an EC2 instance, so let's not do that. But yeah, so cold starts are anything you might encounter. So, but the thing is, if you've got active high spikes, right? Let me go down here. Actually, I think I have to hit like another button or something to get it to training. If we went to active high spikes, the score would go down. Because then you would constantly be running instances of your Lambda functions. And again, better off with EC2 if you're just gonna have 5 Lambda functions running 24/7, best to just have an EC2 instance that you can scale up. Now this low traffic periodic activity, which is, you know, like IoT, great for serverless. Because again, you're only paying for the amount of time that the function is running, and you don't care about a small cold start, depending on the language and the provider that you use. That's great, you're paying way less for your infrastructure. Okay, cool. But yeah, if you're interested in learning more and you're using EC2, definitely check out servers.lol. We came up with that URL as a joke, and then the CEO was like, it's free actually, like it's available. We were like, well, now we gotta buy it. So, yeah, servers.lol. Because I have no idea what I'm doing, most of the time. Okay, so summary. If your functions don't need to be running 24/7, serverless may be for you. If your functions don't take minutes to run, serverless may be for you. If you're not yanking your microphone off your ear with the tape on your neck, serverless may be for you. If your traffic tends to be more sporadic than constant, serverless may be for you. And, you know, you should check it out. I cannot stand up here and say, yes, serverless will work for you if these things, because then I'll get a random person and they'll just walk up to me and they'll be like, well, my app is the one app that fits all of these and it's bad for serverless. And I'll go, okay, I covered that by saying should. Almost never speak in definites. Anyway, what's the catch though, right? There's gotta be a catch, right? There's always a catch. So what's usually the catch with abstractions? When you abstract something in programming, yeah, it gets bigger and more unwieldy, right? Yeah, ditto with, disclaimer before that. I work for a company that specializes in AWS and function monitoring, and all expertise in the subject is affected by that. And while I'm not going to give a sales pitch, I will show an example of our product. Also, my opinions of cloud systems, I will pipe, or otherwise do not necessarily reflect those of my employer. Can you tell I rehearsed that one? Observability and metrics very often are a complete nightmare in serverless. Because you are trying to observe a function running in a runtime that's not yours, in a container that's not yours, on a server that's not yours. So yeah, it can be really tricky. Observability and metrics can be really tricky on serverless and on a lot of providers. Sometimes it can be a downright nightmare. Why? Like I said, the more extracted you are away from the code where it is running, the more difficult it is to see in. Right? And the more difficult it is to see in, the more difficult it is to get information about what's going on out. Right? You can see this right off there. It's like a jawbreaker. It's like trying to figure out what's in the middle of a jawbreaker without like sawing the jawbreaker in half, because you're not allowed to saw an AWS instance in half. Right? So there you go. And we're pretty far out even when we aren't in control of our own environment directly. You can inject environment variables into most serverless instances. So AWS, for instance, will allow you to set environment variables dynamically, so you can kind of fiddle around with that. But other than that, you have very little control over the environment that your function runs in. It's getting better. Serverless providers are getting way better at this. Major props to Azure Functions, all right? Their dev experience is like, as a person who specializes in AWS function observability and monitoring, I'm like, man, those Azure folks got that down. You can run your Azure functions locally, you can step through them, like, they're really good at it. Don't get me wrong, but that's my unbiased opinion of that. They're pretty darn good. Third-party tools are springing up to help. And so now I show you the demo that pays my salary. Also titled, You'll Never Want to Read CloudWatch Logs Again, because you totally did before. All right. So this is the function invocation page for the serverless function that I deployed for that. So this is the activity that we just launched this new sidebar, and it's so much better than the old one, and I love my designer right now because that looks so good. I'm so proud of her. Katie, if you're watching, oh, they can't see it. Darn! Hold on, I will fix this. Katie, they will see your sidebar. There it is. That sidebar is much better than our old sidebar. Katie, when you're watching this on YouTube, love you. Anyway, I'm gonna re-enlarge this. So you can see the number of invocations. I don't know what caused that. That's kind of weird there. Invocation duration kind of spiked. It says, Oh, actually, this was because I forgot to put a return right about there. So you can see the invocation duration went up to like 15 seconds. It's because I forgot to put a return statement in there. Memory usage, right? So like if I need this, so you can set memory limits with Lambdas just like you can with EC2 instances. So if you're using Lambda and you've got it set at like a gig of memory and your graph looks like this, it's like, oh, I could, did I lose the laser pointer? I did, oh, there it goes. If my graph looks like that, I can kind of like say, okay, I can scale down my lambda function. Luckily mine are always set to like minimum. And then invocations with errors. Can you tell I was working on the bot at like midnight last night? Because like I can. Because errors spike it around midnight. Anyway, don't work on your live demos at midnight. Is the answer to this. So this is what I do. I can go into each invocation. So I'm just going to go into the latest one. Right? So this is tracing. Right? So this was the Adafruit IO Connect you saw in here. Mark.start and mark.end. I wanted to see how long it was taking me to connect. It's only taking 78.28 milliseconds, and like it takes 9 seconds when I'm running off a local node server on my laptop, so I'm thinking, what is going on here? But you know, it's good that it's not taking 5 seconds to connect. We do a bunch of stuff with like, if you use API Gateway, oh, this is like super tiny, y'all can't see it. Oh, it's responsive. They launched that too. Katie, you are the best. All right. You can see all the information from CloudWatch here, or sorry, the API Gateway. We just launched logging. So this is what I mean by, I didn't do any logging in this demo, I need to add it, but a Lambda function, if you do console.log, will show up in AWS CloudWatch in about 5 minutes. Cool. So we have real-time logging, that's cool. We just launched that, it's kind of great. So again, third-party tools, like the one I work for, and providers are doing a lot to make the observability problem less of a problem. Cool, I've got super FOMO on serverless now. I want to get started with this. Did I miss it? Did I miss the serverless hype? Is the fact that someone's over here standing on stage yelling about it mean it's over already? No, it's not. We're just getting started with serverless conferences that are just about serverless, so you haven't missed out. Where I would start is serverless.com, which points to the serverless framework. It is a cross-provider framework, so if you are not particularly sold on one platform, you can use it on AWS, Microsoft, I think you can use it on IBM, you can use it on a bunch of different platforms. So I would definitely start there with your serverless journey, and their documentation is super great, and I reference it every day, even though serverless is my job. But, oh come on, who doesn't MDN something every day when they're a web developer? Come on. So, I'm just admitting what we all do. All right, thank you very much for listening. I'm a bit flushed and pale and rambly at this point, but I think I'm holding up all right. Again, I am Cass Perch, they, them, their pronouns. On the Yelly Bird site, I am Node Botanist. I am also Node Botanist on GitHub. I also do lots of robots and stuff. You can ask me about that. I'll try to wear the robot for the rest of the day if I'm not passed out in a chair. And if you want the slides or the demo code, it's at github.com/nodebotanist/empire2018. Tonight's the after party, so I hope everybody has a great, safe night. And if you can't tell, that's Arya and that's Ace, and they're snuggling. And it's really funny because I took this picture. Arya woke up and smacked Ace in the face. Really? Cat, man. All right, that's what I have. Thank you so much.